Hello. We'll have another video here to solve our favorite ODE, or it's my favorite ODE. We're going to use Euler's method. Okay, not to solve, but to approximate the solution. So do Euler's method with h equals 0.1 to approximate the solution to the initial value problem, dy dx is minus 3 times y minus 20, with y of 0 equals 90. We're solving that or approximating that on the interval of x between 0 and 1. Okay, so one of the things we notice is that we need an initial condition for Euler's method. You're not going to find the general solution with the arbitrary constant in it. I'll also might mention, I pointed out that you could just see a little bit of the side of the School of Athens. You can't see much of it. You'll see the reflection of the light if you put that in too much. But you can look up the School of Athens. It's an interesting painting. All right, so let's go on with it. All right, so what we're going to do is this thing here is x naught is 0 and y naught is 90, right? Like that's the typical way we write the initial conditions. Y of x naught is y naught. So what we're going to do now is we're going to update those y's and the way we and the x's. So Euler's method, and note the pronunciation, Euler is a really famous mathematician, is, well, the first thing we have is that xn plus 1 is xn plus h. So h, you can think of h as delta x. In fact, the only reason we say h instead of delta x is because you can write h with a single stroke of the pen, rather than delta x is more complicated to write, okay? All right, now what happens to y? Well, yn plus 1 is the old y, yn, plus it gets updated by the approximation of h times our approximation for dy dx. And what is that? That is f of x and y, and whatever that happens to be. The idea here is that delta y is approximately equal to delta x times dy dx, okay? So delta x is just h, and dy dx is the f of x and yn. Okay, and I evaluate dy dx at the current x and y values, right? This is to solve dy dx is f of xy in general. And in our case, f of xy is minus 3 times y minus 20. It doesn't happen to depend on x, but it could, okay? So let's just do that, okay? For our ODE, we have x naught is 0, y naught is 90, xn plus 1 is xn plus 0.1, and yn plus 1 is yn plus 0.1 times negative 3 times yn minus 20. So I might want to simplify that as yn minus 0.3 times yn minus 20, okay? So I just do that for n equals 0. The first one is n equals 0 to define x1. This is for n equals 0, 1, 2, 3, as far as until I'm satisfied. Okay, so let's do that for this problem, and I've got Excel spreadsheet. There's Excel spreadsheet. I got a blank one going here. I made it a bit big so we can see it. Let's put in our initial x's and y's. So we start x. Actually, let's label it. There's the x and there's the y. Now with the numbering, I can't call it, x0 or anyway, so we might as well give it a label. So the initial x is 0. The initial y is 90, right? So what are the x's? Well, I use a formula. Each of the x's is the previous x. I click above it, plus 0.1. Okay? So I want to extend this down. Okay, well, let's see. I'll go down all the way to here. Well, all right, there. So these are all the x's at each time, you notice, that box is the box above it, A5. A6 is A5 plus 0.1. So that's how it works. Now let's think about the y's. It's another formula. I get whatever is in the box above it. Then my formula is I subtract 0.3 times, and it wants me to put a times. Okay. The guy above it, let me see, I should be here. It's not working. Let's see. Why isn't it? Let's just do it up here. Minus 90. Let's see if that works. B3. I don't know why it says C3. That should say B2. Okay, that doesn't look right. Let's see what happens. So B3 is equal to B2 minus 0.3 times B2 minus 20. And it's not working. There's B2. So let's clear this. Well, I probably have to do this thing again. All right, let's see it. Okay, what is this equal to? That equals the previous minus 0.3 times parentheses the previous There it goes, at minus 69. I don't know what I did wrong, but I think that looks familiar. Let's see if that looks right. Yeah, okay. So then to get the rest of them, it's easier with the mouse than on my laptop, but I just keep going down and do the rest of them. Okay, so it goes down. It's approaching 20. It gets to about 22 degrees C from starting at 90. And this is, of course, just an approximate solution on the interval x from 0 to 1. And if I made h smaller and smaller, I'd get a more and more accurate solution here. All right, bye.